Okay, so there will always be two parts when they ask you for such a question. So the first part has got to do with a sketch. So this is an exponential sketch, which is also very similar to things that is like this under your E-math. So under your E-math, this is also exponential. So when the power is a negative, this is the one that slides down. So this is the one that slides down. So a few examples that slides down will be something like 2 minus x, something like 3 minus x. So this is also exponential. So when you have this graph, right, it is actually 3 point something, no, 2.72. So the value of E is actually 2.72. So it falls under the sliding down part. So if let's say I give you another one, which is something like EX, it is the one that's going up. So it's between the power, whether it's a EX or whether it's a E minus X. So in our case, that is a E minus X. So the graph will be sliding down. So what do you need to take note of? You need to take note of the y-intercept. So if the feature of the graph or the shape of the graph cut through the y-axis, you got to take note of the y-intercept. So this is the one with asymptote on the x-axis. So how do you find the y-intercept? So apparently there's no x-intercept, so don't bother about that. So you substitute x equal to 0 into the equation. Calculator will return you 1, so it will cut at 1. So that will be the sketch for this one. Okay, so usually after the sketch, right, the second part of the question will require you to do a graphical solution. So this happened in E-math, and it also happened in A-math. So there must be an equation for you to solve. So you have an objective to solve an equation. So let's take note. So this is the equation I'm going to solve. I cannot solve it manually for the pure reason x is in the power, x is also not in the power. So this is not something that we can do it manually. Maybe a graphic calculator will be able to do the job. So anyway, we're going to get a graphical solution. That means I'm going to manipulate the equation so as I can achieve the graph. So that I can achieve the graph, and there will be a line that I can add in. So I'm going to manipulate in order to achieve this graph, the graph that I just drawn. Okay, so Isaac, if you take a look, right, you actually can manipulate something like this. Okay, and so this one, right, I can flip over. I can do a flip. I flip the left side, I also flip the right side. Okay, so it's your choice. Or if you find it a bit difficult, maybe we don't do it this way. So we can do it this way. Maybe it's easier if we do it this way. And you already can see the E minus X. So you already can see the E minus X. So you divide by 2 on both sides, you get a half X minus 1. So this is your graph. Your graph is equal to the straight line. So this is going to be the straight line that you are going to add in. So if you read the question, insert the sketch, an additional line. So what line are you inserting? You are going to insert this line. So if I want to insert this line, I should take note of the x-intercept and the y-intercept of this line. So Isaac, you got to like mentally, or you can work it out. Think about the x-intercept. Think about the y-intercept. I think the y-intercept is quite obvious. The y-intercept is a -1. And then, right, I think if you mental out or you calculate the x-intercept, I think you will get a 2. So maybe 2 is somewhere here. Okay, or here. So that will be the line I'm adding in. So where is the solution? So if let's say I can read it off the graph, the solution is at the intersection. So the solution to the equation is the intersection. It will come from the intersection between the graph and the straight line. So that will be how the phrasing of the question will be like. So usually they ask you to do a simple sketch. And then the second part is the manipulation. So the direction of manipulation should be from the equation. You manipulate trying to achieve the graph. This is the direction of manipulation. Don't go and manipulate the other way around. Common mistake, people manipulate the other way around. So I manipulate the equation and eventually I can get a graph equal to a straight line. So that straight line is the one that I'm going to add on so that I can find the intersection. That intersection will represent the solution for the equation that we couldn't solve.